Hi, in this lecture I'm going to show you how we can actually work with the two-dimensional array. So let us start by creating a 2D array. So let's say we have an array in which we can have up to 100 rows and 100 columns. And maybe then we will ask the user, give us the number of rows and columns, and we will take input the number of rows and the number of columns. So n denotes rows and m denotes columns, and you can use any variables. So one thing you may ask is, we have defined the initial size as 100. So generally in most questions it would be given, the constraints would be given. Okay, maybe the maximum value of n could be 1000. So in that case you can just make it as 1005 or something like this. So okay, so now what we are going to do, we are going to take input. So either we can make a method that take inputs, or we can directly take input here as well. So let us directly take input for int I equal to 0, I less than n, I plus plus. So we are going to iterate over rows, and then we are going to iterate over the columns, and we are going to take input and store the input in array of I comma j. So let me tell you what we are trying to do. So the indexing of this array, so this should be j. The indexing of the array starts from index 0. Okay, so if I have something like this, then this index would be 0 comma 0, 0th row, 0th column. Okay, and this is again 0 1 2 3. So this would be 0 1 0 2 0 3. This would be 1 0 1 1 1 2 1 3, and 2 0 2 1 2 2 and 2 3. So effectively you can see we had 3 rows and we had 4 columns, and the last index is nothing but n minus 1 comma m minus 1. Okay, so it goes from 0 0, the matrix starts from 0 0, and it goes till n minus 1 comma m minus 1. So that is why we have written less than m and j less than m. So we are going to iterate row by row, and we are going to take input these values, and once we are done we can also do the printing. So let us write the print function, and maybe for this we are going to write a function print, and this will teach you how you can pass a 2D array to a method. So I can say, okay, I want to pass in a 2D array. When you're going to pass a 2D array, passing the number of rows is optional, but you must pass the number of columns. The number of columns that we have defined here is 100. This must be fixed, and then we pass in the value of n and m, because from this information we don't know how many rows and columns do we actually have. Okay, so ideally what is happening now is the array is actually pretty big, but we are just using a small part of the array. Maybe we are just using this part of the array, and we are telling the method that when you're going to iterate, you just iterate over this part of the array. Okay, so we are not going to iterate on the entire array. So that's why we tell, okay, we have m number of columns and we have n number of rows, and ideally the entire array is actually big, so it is 100 cross 100, but we are just going to use, let's say, 3 cross something like this. All right, so let's see what we are going to do now. So printing would be similar. So we need two nested loops. So one, the loop for I, which goes from 0 less than n I plus plus. So first we iterate on the, we set the row as 0, and then we iterate over all the columns of that particular row. So int j equals 0, j less than m, j plus plus, and here we are going to print the row cout array of I and j followed by some space, and once a row is done we can simply do a handle here. Okay, so let's build the code, and now let's call the function. Let's print the array, and let me show it to you. I can say print the array which has n rows and m columns. So when you're passing this array, it is again passed by reference. That means we are sending the address of the array, we are not making a copy of the array. So this is again like a 1D array, this is also passed by reference. So any changes that you make here would be reflected in the main as well. So this is something that you should note. So let's test our code. Dot slash it's 2D array basic. Let's say 3 rows 4 columns, and I'm going to give the input. So input, either we can give one by one or we can give row by row. Okay, so it doesn't matter, or we can give all the elements in a single row. So I need to give 12 elements maybe, and let's say last 4 are 0 0 0 1. Okay, I think we forgot to call the print method. Now it should work fine. 3 rows 4 columns. Yes, so we can see this is the array, and we are actually able to see a 2D array. One thing I want to talk about is how these arrays are actually stored inside the memory. So we can see the output we can see is in the form of a 2D array, because we have given a new line character after every row. But what happens in the memory level, how they are stored? So is memory 2D or is it 1D? So basically there are two ways in which the memory can handle the storage of a 2D array. Okay, so this is something that you don't need to worry about. This is something that the underlying API takes care of. So there are two common notations. One is known as row major form and another is known as column major form. And let us talk about what is the difference between these two forms. So row major form basically stores everything that is in one row, that is stored together like this. Then the next row is kept adjacent to the first row. Okay, so the next row is like this one. So this assumes we have actually a 3x4 array, but if in our case we have an array of, let's say, 100x100, but we are using just 4 columns. So in that case the 100 columns are lying here and we are just using this part of the memory. Then the next 100 columns are lying here and we are just using this part of the memory, and so on. Okay, so this is what the row major form is. So if this address is, let's say, 101 100, this is 104, this is 108, this is 1112, and the next address, this would be nothing but 116. Okay, because it is part of a linear memory. So this address is going to be 116 and this is going to be 100. Similarly, this address would be nothing but 132. So I hope you understood what row major form is. And in some systems, depending upon the architecture, the array might be stored in the form of a column major fashion as well, in which each column is stored in a row, and then the next column is put adjacent to each this one, then the next column, and so on. So yeah, so this is how these are actually stored in the memory, but this form is the most common and most computers are going to use the row major form. So that's it. That's all for this lecture, and thank you for watching.